Maybe it already success on the second, right? Maybe it's success on the third. So this SBLR will be lower than the first. Okay, now there's also retransmission rate, right? So it's similar, but talking about the percentage, how many percent of the packet being sent is retransmission, not the first one, right? Okay. There's also HSDSCH code use, right? So they are asking like how many code is being used right now, right? How many available and used right now? If you do FTP, the maximum is 15, right? 15 code use, but you know, it changes so fast. So we use an average to show you, like every second. Maybe it will be 13.1, 13.2. So some people ask, hey, it's impossible. It's going to be 13 or 14, right? But no, actually, because it's like 500 slots a second, right? So it's changed a lot. So it's going to be average. And then this is the average. So the more you get higher to 15, it will be faster data. Similarly, we are talking about the modulation, right? Modulation. And this is the modulation percentage. QPSK, 16 gram, 64 gram. So, like in 1 second, right, HSDPA transmits on 2 millisecond frame, right? So in 1 second, you know, in that 500 slots, how many were using QPSK? How many percent? How many percent using 16 gram? How many percent using 64 gram? Right? So if your network configured 64 gram already and is using this 100%, oh, you have good throughput, right? Having good throughput. Okay. Now, okay, there's the next important one is the CQI. This is normally you will look at this CQI to get an average idea that how is the channel quality right now, channel quality index, right? So they are quite confusing because there are 5 CQI here, right? So which one means what? Okay. So this HSDPA CQI only, these are for the older phones, like HTC Explorer, right? The older ones which not have dual carrier support. Okay, that one you will see this CQI. But on the newer phones, there's not this. This one will be blank, right? You will have HSDPA CQI-A, CQI-B, or dual carrier CQI. So the thing is that you will either have a CQI-A or CQI-B showing, right? So it's from 1 to 30, right? The 30 is highest, very good quality, right? So like 10, 15 is okay, right? Lower is quite bad. So this one they will look at, and it will be in the Excel report, the plot of the CQI. Either one, if you are not using dual carrier at that time. But if you are the network and your phone configured and use dual carrier, this CQI-A, CQI-B will not show. It will show CQI-DC primary carrier or secondary carrier, both at the same time. So what is the CQI first, second, it will show here. Okay, so now back to the CQI complete, back to the one between CQI. This is talking about the slots, right? Demod attempt, demod valid. So like I said, it was HSDPA, the slot is 2 milliseconds, right? So one second has 500 slots, right? So in this 500 slots, how many slots did the phone try to decode? Is the next slot mine or not? Is it mine? Is it mine? Right? Normally, when you are connected to FTP, it will be the same, right? So measurement slot and demod, the phone will always try to demodulate if it's mine or not, right? Now when it tries to demodulate, how many is getting valid? Valid means it is of your phone, right? So suppose there are 500 slots, and then it demodulated, and then it found that 300 was for the phone, right? So only in that 300 slot the data is actually being sent. The other 200 is waiting. It's someone else's data. Because HSDPA is shared channel, right? It's sharing with other people. So for this sharing, this ratio, it becomes HSSCCH usage percent, right? So if you are using, your FTP server is fast, right? Your phone is good, it's fast, but there are many people using at the same time, right? So this percentage and the throughput is slow. This one will percentage will go down, right? But sometimes there are many type of configuration, multiplexing in this kind. So some people will not call it usage percent. Some people will call it the not valid percent, right? So it depends on the tool. Some tool call it this, some tool call it that. Okay. Let me scroll to the next. Okay, that is mostly what normally you will look at. The others are not so much looked at, right? It's like dual carrier on how many percent in the last second was used. Okay, now on to the HSUPA. Okay, now HSUPA here you are seeing showing up because it's using the old packet as in the older phones. So this phone, luckily we have HSUPA already up. So let's look at the HSUPA parameters. Normally when the phone is either doing download, this script is doing download, right? There will still be some data being uploaded too. So that is why you see the throughput here, even it's doing download script, right? But it will not be high. It's just sending control, signaling information for HTTP or FTP, whatever you are using. But these are the, similarly to the throughput in HSDP, these are the ones you will look at. There's raw throughput, scheduled throughput, final DPD, dedicated physical data channel throughput. This is the one you'll be using, similar to what I explained for HSDP. For HSDP, normally in the report, the highest throughput will look best for you is final DPD-CH throughput, right? So this is the one you'll choose from the report. The others are not in the report, just for you to look on the phone. Suppose you want to identify some scheduling issue. Similarly, there's the SBLER for HSUPA. Right? How much BLER? You look at this one. Now this is the transmission time interval TTI 10. Right? So what is this? The TTI of HSDPA we were talking just now is only 2 milliseconds. Right? So it's fixed. You are sharing with other people, but it's fixed 2 milliseconds. So, but here in HSUPA, if you are not doing so much upload, right? Like this one, we are doing download script. So there's only, okay, we are doing only little data being uploaded, right? So the TTI being used is 10. So in HSUPA, you have 2 gears, right? Gear 1 is 10 milliseconds for slow upload. Gear 2, doing high upload, uploading photo, FTP upload. This one can be changed to 2 milliseconds, right? The network phone would decide and then use 2 milliseconds. Now, similarly, there's this HSUPA happy bit TTI, right? So this is also, they like to look in the report that how many percentage of the TTI used is the phone is saying it is happy, means that the power and the allowance of the network and so on, the phone is saying, okay, I'm quite okay with this. It doesn't want to send so many feedback to the network to waste throughput. It's just sending one bit, happy, not happy. So how many percentage was it happy? This is the happy bit TTI. And there's also the new transmission, free transmission, that's clear. And also there's the DTX. If it's not sending, it's sending using TTI high, but it's sending low, not so much data, or right now it's not sending, you see the DTX has become quite high. So just discontinuous transmission, it's just waiting, doing nothing, right? Okay, and there are some other parameters, but normally you don't use it. There's like 7 grand index is talking about the what power. This is from the 3GPP spec. It will tell that which SGI allow to use what power limit, right? So that's, but not mostly used. Normally you just look at this final and TTI, SBLER, happy bits, right? That's for HSUPA. Okay, 3G barriers, right? The third tab down. This one is talking about the barrier assigned from network to phone, right? So this one is also interesting. Now, right now we have one barrier with this much rate DL, this much rate UL. Sometimes the network can set it down to lower, slower, but let's make a call right now and see what's the difference. Okay, so now we are making a call. It's getting into cell DCH. You see the barrel has changed. There are 3 more barrels, right? These are quite slow. What is it for? For the voice call we are making right now, right? This one, the first one, this is for the data, right? So these are the AMR class A, class B, class C bits. It's being sent together, but it's not using the same pipe, not using the same barrel as the data, right? Of course, this is a circuit switch barrel. This is packet switch barrel. So when they test, you want to do a multi-wrap test. So you want to test how is the phone performing FTP and voice when they are using both at the same time. So in that situation, you can in the script, in the execute script, instead of voice dial or FTP, you can choose multi-wrap. It will be FTP and voice, right? Voice and ping, right, together at the same time. So that is multi-wrap. But you want to see actually if multi-wrap actually used right now, you come to the barrels and see if it's 4 barrel, right? Normally it's multi-wrap now. If it's one, it's only data now. If it's 3, it's only voice now. So you can look from here. Okay, that's it for WCDMA. We'll get into LTE next. Okay, forcing LTE. Now drag to go back to.
Remember that the setting stays whenever you restart the phone. So sometimes if you set this to LTE and then next time you go into a GSM area, it will always be no service. So,
yes, so
please remember, if you set the settings in here,
yes,
you have to go back and change it.
Yes. Okay, so now we're talking about LTE. You can see that LTE, there are so many parameters. Of course, when you are RAT change, the top of the screen will change automatically to the current RAT, right? Radio access technology. So now in LTE radio, there was question about, so now we're in LTE. There are so many parameters. There's band, UFCN, PCI, ISRP, right? Of the first antenna, 0. This is of the first antenna. 1. This is of the second antenna, right? But the ISRP actually use, it will in the Qualcomm chip, it will choose the highest one of the 2, right? So you see now this one and this one is the same, right? So if this change, it will use this one instead. So that is for your measurement. ISRP is using which one? Okay, similarly, ISRQ there will be 3, SINR there will be 3, ISSI there will be 3. So it's like antenna 0, antenna 1, what is the best, right? Okay, on the top you're already seeing like what is the best one. Now what is this PCC, SCC? Why this is nothing here, right? So, okay, so that's because there's in further LTE there will be carrier aggregation, right? So in newer devices, right, like Samsung Galaxy Note 4, right? Those devices you will start seeing carrier aggregation. So it's same thing like dual carrier in WCDMA HSDPA. So it wants to use more carrier at the same time, more spectrum at the same time to get even faster throughput. So they call those LTE Advanced, LTE-CA carrier aggregation. You will see SCC here also. But for this model, Lenovo, there's no SCC, and I think the network not open also. So that's very rare. You will see this. So no need to worry about SCC. So that's secondary component carrier. Normally we just look at primary component carrier, right? Okay. So similarly to WCMA, GSM, the most important, of course, is IX level. Everyone understands, right? And there's the sub, right? Normally we will look at sub to avoid the downlink DTX effect. Right? The full, it will consider all the channels, right? The sub will consider only the one that always come. It is not affected by downlink DTX, like the SACCH. These are always guaranteed to come. So if you use IX level sub, IX core sub, no effect from downlink DTX. You use full, if there's no DTX, it's okay. But if there's DTX, it will drop down. Right? Similarly for WCDMA, just going back again, most important is of course the EC by IO. Right? ECNO is actually the same thing. There's theoretical difference between ECIO and ECNO about the thermal interference, but in practice, Qualcomm has a knowledge base article saying that it's the same thing, using the same one in their radio chips. So that's the same one you see in the measurement report of the 3GP saying ECNO and ECIO here. So don't worry about ECNO, ECIO, but that is the most important. More than the RSCP, right? So like everyone understands that ECIO is like WCDMA is a interference limited system, right? GSM, the more stronger you broadcast the phone receive while not interfering at the same FCN, that's good. But WCDMA, you want to be the lowest but audible, so it will not interfere. So ECIO is showing that. ICP is showing how loud is the language, right? The language, the scamming code is broadcasting. ECIO is showing how loud compared to other languages. So it's broadcasting same time, but how loud compared to others. So we see some logs, right? ICP minus 55, very strong, right? Very strong. ISIS-I also strong, but call drop because there's too much interference, right? So that's about. Similarly, when you come to LTE. Normally they will look at SINR, ISRQ to understand the same. This one is the coverage. The more technology goes, normally the signal coverage is being lower and lower, right? Before, if you see IX level minus this much, how bad would it be? Right? IX level minus 110 is, no, it's not going to work, right? But when you come to WCDMA, it becomes a lower requirement. Come to LTE, it becomes lower requirement. The most important becomes the SINR, the ECIO, which is same as C over I, similarly, right, to some extent. So here most important is like SINR, ISRQ. Okay. So let's go on to see some other parameters. Now for LTE, I understand it's just going through some basics. Again, refresher. That is only packet switch, right? No more circuit switch in LTE anymore. So immediately you want to look at BLER and CQI, as in HSDPA. But CQI in LTE now the maximum is 15, not 30, right? I don't understand why, but that's how it is. So now if you have a CQI 15, it's excellent. Here is 8, it's moderate. Right. Okay. There's also TX power, PUCCH. Let me scroll down. TX power, timing advance. You can see here. Where is it? Yeah. TX power, PUCCH, PUSCH, timing advance, transmission mode, RC state, EMM state. Right. What is the non-access stratum state? Right. And there's some other information. MNC, MCC, tag, CLID. This kind of thing can sometimes, if you just start as a queue in the netmon, sometimes this one not show yet. As I said, because the registration happened before that. So enter exit airplane mode to get this to show, right, for the first time. So we recommend to put some weight in the script to do this before it start testing. A pause, right? You can press unpause. After you get this done, GPS slash ready, then press unpause, right? Not that is pause in the script, not pause in here. That's different, right? I can show you after this. But let me explain here. There was like question that so how can I know it's a TDD or it's FDD, right? So there are two ways. Normally, if you are using TDD, the band will be 40 something, right? It will not be low number. That's one way you can look. another way is the DL and UL ERFCN. If you are using here, you see it's different, right? But if you are using TDD, it's time division. It will be the same because it's using same frequency. But here, different. So FDD, right? So a simple way to look at that. Now here, also if you did enter exit airplane mode, this information will come like UL bandwidth, DL bandwidth, how many megahertz used, right? So this is quite low, but maybe it's like about the spectrum limitation, right? Somewhere you can see 10 megahertz, 20 megahertz, you will have much faster throughput. If it's using TDD and you enter exit airplane mode, there will be the subframe assignment, right? And special subframe pattern. That is from the L3 extracted to show you here, you know, these numbers. Like there's a TDD is like UL and DL, right? But it's not going to swap all the time. DL, UL, DL, UL. No. Maybe DL, 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 then UL. Or DL, DL, UL. You know, so what configuration that is in the 3GPP specification, it will tell you here from the subframe assignment. Then you can refer to the 3GPP spec to see actually what type is using, right? So that's about the TDD. Graph is same, right? So it's just a graph of the main parameters. Okay, now you go to the next step, LTE cells. So there's like the EFCN, band, PCI, ASA, P, ASA, Q, just generic stuff. Okay, now more interesting part is the LTE data tab. Right. So now similarly to what we were looking just now, there's a, instead of the confusing schedule rate, serve rate, you know, we show now one for LTE. Let's just look at this, right? This is the L1 throughput combined. You know,
it may look little, but it's in
yes.
Mbps, so
yes.
it's actually fast.
Yes, this is in Mbps, right? So if the phone is doing idle, you'll see little. If it's doing FTP, it'll be a little more. But LTE now we're not showing kbps because it's so fast. Sometimes we have 7 Mbps.
You have 200,
70, yeah, right? Sometimes have 200. So now I assume it's doing FTP now, right? And there's some, just now 2 Mbps, 3 Mbps, just little bit, 5 MB complete. So now it's waiting. Yeah, so some data are flowing for other apps. Okay, the RRC transmission mode. This is also quite interesting, and it relates to transmode currents. In the 3GPP specification, you can look in the specs, there will be quite many transmission modes, right? This relates to MIMO, or transmit diversity, or single port. So if you look in the specs, normally from the LTE networks deployed today, you will see normally, mostly only 3 types. 1, 2, or 3. Right? You can go to the specs, but I'll just outline that 1 here. If this is 1, okay, again, enter exit airplane mode. If this is start again before the script. If this is 1, here transmission mode current will always be single port, right? Single port. And the end serving TX antenna of the network will be 1. So transmission mode 1 means that the E node B, right? The BTS, whatever, same thing. As when 3G become node B, 4G become E node B. So the E node B, if it's 1, E node B has only like 1 antenna to transmit. So there's only single port of data also. So that one they will say single port if the RC transmission mode is 1. If it's 2, the end transmit antenna of the E node B is 2, but there's only one source of data to flow. That means transmit diversity, but no MIMO. MIMO not supported if it's 2, right? So here it is 3, right? So it is 3. So 3 means that it can support MIMO. The network can. The E node B is capable of supporting MIMO. But MIMO will happen only when the situation is suitable. And that is when the rank becomes 2, right? So this rank is actually, you know, MIMO, the network support but it cannot work all the time, right? So you know, before GSM, WSMA, there was like they call multipath, right? There's a reflection, right? BTS transmit to phone, right? Sometimes it reflect with the board and then it come again, right? Like echo, right? Yeah, but it becomes a disturbance to the phone, disturbance to the network, right? So now in the new releases, the 3GP think that let's use this reflection tool. We have two antennas, and then we transmit. The phone can detect which data is coming from which antenna. First, the network will transmit the same thing on both antennas, but the phone can identify if it's receiving differently between antenna 1, antenna 2. Does it match to the network's antenna 1, antenna 2 individually or not? If sometimes the network transmit and it's going to multipath, reflect there or reflect here, and then the phone can identify that there are two separate channels, right? Then the phone will tell the rank to the network, right? That two. If the phone is receiving, it cannot say, oh, I can't differentiate 1 and 2. There's too much reflection or there's no reflection, right? It will be 1. So phone will tell network that 1. So network will say, okay, I will transmit diversity. So I'll transmit the same thing on both the antennas. This one means MIMO is not working yet, right? The radio condition is not supportive of MIMO. Network has MIMO capability, phone has MIMO capability, but is not reflecting good enough. Okay, but after some time, you see the spatial rank indicator, it becomes 2. Then the network immediately will transmit different data, right? So instead, it is saying same data. Antenna 1 send ABC, antenna 2 send ABC. So when MIMO is on, antenna 1 send A, antenna 2 send B, right? So it's double speed, right? Antenna 1 send AC. This one can send BE, right? So it's double throughput at the same time. So you can see in the replay, sometimes when MIMO is on and off, the throughput L1 will go like this, like great swing up and down, because MIMO sometimes on, sometimes off very frequently. So now you see when it's 2, it becomes open loop spatial multiplexing. So this one means, oh, right now MIMO is working, right? So this is about MIMO. The rest is the same, EFCN, PCI. PCI is the new thing, the new PSC, right? New PSC is PCI. BLER, same thing. N transmit antenna of serving cell, and RX antenna of serving cell, spatial rank indicator. Spatial rank essentially is like what phone detect, but it will periodically tell the network that is the rank indicator. So it will detect maybe faster, and then this one will change after that. Then network will change to open loop spatial diversity. Right. Okay, now there's also the CQI in this page, because this is data, also same as that page, same thing. 15 is the best. And this is NRBs allocated and NRB max. So in LTE, we are talking about the resource blocks, right? So resource block is LTE. There's also both a mix of time division and frequency division to call frequency time. A block there is resource block. So they call this OFDMA, something like that. Right. So how many resource blocks is maximum? We did enter-exit airplane already. We have the DL bandwidth, right? Megahertz is 5. So now in this 5, if you divide into resource block, it's 25 resource block. Now, for the current situation of the download, maybe it's doing FTP or not, it's idle or not, it's sharing too much or not. How many resource blocks is actually allocated by the network at that instant? You see here. So here is 25 network has allocate 25. Oh, it's good situation. You're having the good situation, very good. Maybe now the FTP ended 5 megabyte already. It will stop and go down. So you see this becoming good, very full, and then it go down because it stopped FTP already. Only 5 megabytes is very little for LTE. And then now you see the time scheduled percentage. time schedule percentage is similar to what we talked just now about the SCCH usage percent, right? In WCDMA, right? What is the usage percent? How many slots is ours? How many slots is others? Right? That is in 3G. A little different in the 4G. Essentially the same thing, but a little different that this one will consider mostly what is coming in between. That is considered the whole time. But sometimes this one we want to consider what is coming in between. So if FTP is starting, right, you can see this becoming very high, right? And then when it's done, it go low. You see now the throughput running. This is quite high. Now you see after some time, this one go down. This one go to 2%. Else FTP done, right? Okay. So when it's high, it means that during our transmission network sending to us is not sharing with anyone else. If this packet is mine, this packet is mine. If how many percentage is coming in the middle for others, right? So this is like time sharing, time schedule percent. So this is high, is good. Situation network is we are not having too much sharing at the moment.
Means nobody use LTE.
Yeah, at this moment sharing, no resource conflict, right? If this is low and you're already in FTP 1 GB, network is FTP server fast, no problem. But still this is low. Oh, there's a lot of sharing at the moment here, right? A lot of resource sharing. Okay. There's also here the MCS. Right? MCS is a modulation and coding scheme index. Similar to the SGI in SS UPA, this one needs to be looked up in the 3GPP table. That what is the MCX is using at this moment. But more easily, we can look at the modulation only and the block size, right? So here we want similar to 3G HSGPA. You can see what modulation is using right now. Okay, it was a QPSK 16 gram or 64 gram. So let's wait until the FTP start again. You can see now it's using QPSK and 16 gram. Maybe the CQI is not so good, so it's not going to 64 gram. Or maybe the file is F5 MB also, it might be. So let's see. Now you can see another thing is the block size in bits. So if MIMO is on, you will see the block size of both the S0 stream, right? Stream 0 and stream 1. So if it's MIMO is on, you will see that it's flowing for both. If it's not, it will flow only for the first one, right? Maybe it's getting on, but data not sent on the second one. Maybe it's too small, right? So let's recommend it. Normally FTP for LTE use 1 gigabyte. 1 gigabyte. Normally we do that, right? Okay, and then the traffic ratio. Okay, that's normally not used. The rest is voice over LTE. I understand is not deployed yet, right? Okay. Now let me try another thing. Is we have completed all the parameters already. Let us try something like CS fallback. Right? Now we are forcing LTE only. Right? If I do CS voice call now, it might not call because there's no voice of LTE. But maybe the Lenovo. Okay, see, it's not calling because we are forced to LTE only, right? So what to do? We go back to the force screen, right? And then we set it to the first one. Okay. Okay. And then now we try to call again. Okay, you see immediately it becomes edge there. So means that there was a CS fallback, right? Okay, now okay. Now you can see here, you can scroll in the events what happened just now when we did LTE call, voice calling LTE while not locked to LTE, right? So there's call initiation, right? And then there's a non-extra stratum extended service request telling that this originating circuit switch fallback or 1x CS fallback if the phone is CS fallback to CDMA. But here no, we are CS fallback to WCDMA, right? And then there's an attempt mobile CS fallback attempt event here. Immediately there's a LTE redirection, right? There are two types CS fallback. There's a mobility from eUltra, that is handover command, right? Directly handover command to 3G. But sometimes it's using, let me scroll back. Sometimes it's using redirection. Redirection is a RC connection release. Instead of sending handover command to 3G, right? Mobility from eUltra, right? It will send RC connection release. That's also okay. But in the RC connection release, it will tell you which UFCN to hand over to. So the phone, the network send release, but the phone understand that this is not normal release. Special release telling me to do a new voice call after reselecting to UFCN 10757, right? So what happened next? The phone reselect, right? Redirected, actually they call it redirect. Now here it becomes 3G. There's CM service request, routing area update, authentication, call confirm. So now we are here already in 3G. The normal call setup established thing happen. FTP, HTTP is also happening at the same time. So we are also doing multi-rep now. So now, what if I end the call, right? I end the call here. Okay? Immediately it go back to LTE. So this is the end of the CS fallback procedure. So what did we see? When we hang up the call here, call end, see? Call end. We have WCDMA redirection to eUltra. Anything with E in front is actually LTE. Yeah, so anything with U is WCDMA. Yeah, so ARCN become UFCN. UFCN become eARCN. Right? So here is the RC connection release of WCDMA. After we end the call, CC disconnect, whatever the normal release, the RC connection release sent. There's a special same technique. It's sending. Please redirect to this eARFCN, not this one. Okay. Please reselect to this EFCN. You can see now it already followed that command, right? So we have redirection coming. Then we have LTE TAU. That's not tower, right? It's the tracking area update, right? Request accepted, completed. And then we are on LTE. So now the FTP is continuing in LTE. So these are the CS fallback sequence. In the Excel, you will have automatic CS fallback criteria, right? How long did it take to make a CS fallback from LTE to WCDMA? How long did it take to reselect back from WCDMA to LTE? Right? So that's also covered here by using AZQ. Okay. Now we complete the data. Talk a little bit about voice over LTE tab. Here, normally you won't see anything because you are using CS fallback. But when you start to use voice over LTE, you'll see the speech codec, and after some configuration, you will start to see this AMR packet delay, RDP packet delay. But essentially, it might not be happening in the near future. But just to tell you that voice over LTE is just trying to implement something like you are using WhatsApp, calling, Tango calling, Skype calling on the phone. Those are all packet switch, right? They are using internet. But voice over LTE understands, is trying to fix the problem that most of these internet-based calls are happening. The main problem of packet switch is that is not coming so fast connected to each other. When you have used circuit switch, you are sending little data, but at very sure sequence. It will always come, right? Little data, but it is very consecutive. It must always come. If you make a voice call, someone talking, maybe you hear not clear, but you will hear what he's saying, right? But packet switch, when you want to use packet switch for voice, the problem is that there's so much routing, there's so much waiting that you will hear lag. So when you use Skype, you use this Tango, Google Hangout call. The problem of all this internet calling is lag. If you use circuit switch, maybe it's not clear, but there's no lag, very little lag, right? So this lag, to fix it, they define voice over LTE. Voice over LTE is, same like we were talking about barrier just now. There's a LTE for 3G, right? There's data barrier, there's voice barrier. For LTE, there's only packet switch, but they want to make a new barrier specially for voice. So it's like they have the normal barrier for internet. Okay, if you use Skype call, you use Tango call, it will use that normal barrier. It will wait for internet with other people. It will wait for your email. It will wait for your Facebook. So voice will be slow. But when voice over LTE, it uses a new barrier, right? That is something to imitate the circuit switch, sequence of being, like slow but sure, right? Packet switch normally is fast but not sure. So it's fast, maybe it comes so fast, 1 Mbps, then you wait. It's not acceptable for voice. For voice, you don't want fast, but you want sure. It must always come to not feel the lag. So voice over LTE, they make a new barrier which has, they say, QCI1, right? So it's like having highest priority than the other internet barriers. So they hope that the lagging will go away. But on that internet barrier, the same technique is used similarly to what is used by Skype or others. Just that you run it on a different barrier. Same technique, that means SIP. If anyone heard of SIP, that is the session initiation protocol used to create a session for voice over LTE. Then they send the AMR packets through RTP. Right? Then you get to hear voice on voice over LTE. Now they say that one cell, some equipment vendors say it can support up to 400 calls at the same time. I don't know, this advertisement somewhere. So that is the hope for voice over LTE and LTE. So you don't have circuit switch in the network anymore. You don't have to worry about the old SS7 equipment in the network. Right? You just, everything is AIPN, all IP network. Right? No more circuit switch support, and same network have high throughput and voice. Everyone happy. That's what they say. Right? Okay. So that's the end of the parameters walkthrough. Any questions, sir?